Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem: solve d plus 2 into d minus 1 whole cube into y equals to e power x. So firstly, let's find order and degree of the given equation. We are given d plus 2 into d minus 1 whole cube into y equals to e power x. You know that a minus b whole cube equals to a cube minus b cube minus 3ab into a minus b, right? Which is equals to a cube minus b cube minus 3a square b minus into minus plus 3ab square. Now, you can just write LHS part as, now you can expand d minus 1 whole cube using this formula for a equals to d and b equals to 1. You'll get d cube minus 1 cube minus 3 into d square into 1 plus 3 into a d into b square 1 square into y equals to e power x. This becomes d plus 2 into d cube minus 1 minus 3d square plus 3d into y equals to e power x. Then d times d cube minus 1 minus 3d square plus 3d plus 2 times d cube minus 1 minus 3d square plus 3d into y equals to e power x. So from this we'll get d into d cube d power 4 minus d into 1 d minus 3 d into d square d cube plus 3d into d 3d square plus 2d cube minus 2 into 1 2 minus 2 3s are 6d square plus 2 3s are 6d into y equals to e power x. Then d power 4, you're having only two d cube terms, so you'll get minus 3d cube plus 2d cube is minus 1d cube. Now identify the squares. Plus d square minus 6d square is minus 3d square. Now identify terms involving d. Plus 6d minus d is plus 5d. Constants minus 2 into y equals to e power x. So we can write the given equation as d power 4 minus d cube minus 3d square plus 5d minus 2 into y equals to e power x, right? Now consider this equation. D power 4 minus, we'll just simplify this, okay? Plus 5d minus 2 into y equals to e power x. Now we can write this as, multiply all these 5 terms with y, then you'll get d power 4 into y minus d cube y minus 3d square y plus 5dy minus 2y equals to e power x, right? We know that differential operator is d by dx. Differential operator d can be written as d by dx, right? So d power 4y can be written as d power 4y by dx power 4 minus d cube y by dx cube minus 3d square y by dx square plus 5 into dy by dx minus 2y equals to e power x. Now identify the highest derivative. So here d power 4 y by dx power 4 is the highest derivative. So our order will be 4 and degree, the highest power of the highest derivative. So here derivative, the highest derivative is d power 4 y by dx power 4. The highest power of the highest derivatives are degree. So our degree is 1. Now coming to the problem. Solution: given differential equation d plus 2 into d minus 1 whole cube into y equals to e power x, which is in operator form. F of d into y equals to q, where f of d equals to, by comparing these two, we'll get f of d equals to d plus 2 into d minus 1 whole cube and q equals to e power x, right? Now, we need to find the general solution to the given non-homogeneous equation using y equals to complementary function plus particular integral. We'll find complementary function by using roots of auxiliary equation of homogeneous equation of the given non-homogeneous equation, and we'll find yp using 1 by f of d into q, right? So now firstly we'll find complementary function using the auxiliary equation of homogeneous equation of this non-homogeneous equation. The auxiliary equation of f of d into y equals to 0 is, if you consider RHS part as 0, you'll get a homogeneous equation of this non-homogeneous equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, replace differential operator d in f of d by m, then you'll get m plus 2 into m minus 1 whole cube. Then our auxiliary equation becomes m plus 2 into m minus 1 whole cube equals to 0, right? And here you can write m minus 1 whole cube as m minus 1 into m minus 1 into m minus 1 equals to 0. Now equate each factor to 0. If you equate m plus 2 equals to 0, you get m equals to minus 2. If you equate m minus 1, here we are having 3 m minus 1s, right? So if you equate m minus 1 to 0, you'll get m equals to 1. Then our roots will be m equals to minus 2, 1, 1, 1, right? 1 is repeating thrice and minus 2 is a distinct root. So m equals to minus 2, 1, 1, 1 are the roots of the auxiliary equation. Therefore, m equals to minus 2, 1, 1, 1 are the roots of f of m equals to 0, which are equal and distinct. That means 3 equal roots and 1 distinct root. So here we have 3 equal roots and one distinct root, right? Here minus 2 is a distinct root and 1 is a equal root. We are having 3 equal roots. Fine. Now let's write the complementary function. One is equal root and minus 2 is a distinct root. Okay. We know that if 3 roots are equal, say m1 equals to m2 equals to m3, then the solution is given by c1 plus c2x plus c3x square into e power equal root, say some m1 into x, right? If we have distinct root, then we'll get some constant into e power distinct root into x, right? If you have 3, then this is the complementary function. If you have one distinct root, then this is the solution. What happens if we have 3 equal roots and one distinct root? We have to add these 2. Therefore, a complementary function is yc equals to, firstly you can write for distinct root, c1 e power minus 2x plus, now write for equal roots. You are having 3 equal roots, so you will get 3 constants inside the brackets into e power equal root into x. Because here I am having minus 2 first, so I wrote a solution for the distinct root. Okay, here you are having distinct root firstly, so we'll write solution to this distinct root first, and then we wrote for equal roots, 3 equal roots. Then yc equals to c1 e power minus 2x plus c2 plus c3x plus c4 x square into e power x. Therefore, yc equals to c1 e power minus 2x plus c2 plus c3x plus c4 x square into e power x. Now let's find particular integral. We know that particular integral is given by yp equals to 1 by f of d into q, which is equals to, we have f of d, d plus 2 into d minus 1 whole cube into q e power x. So here we are having 1 by f of d into e power ax form, where a is a real number, right? Now we can expand this f of d. Already we have expanded this, which is d power 4 minus d cube minus 3d square plus 5d minus 2, right? So we'll replace the denominator by this expansion, d power 4 minus d cube, that is the result obtained from expansion, minus 3d square plus 5d minus 2 into e power x, right? So we have f of d Let's find f of 1, right? F of 1, which is equals to 1 power 4 minus 1 cube minus 3 into 1 square plus 5 into 1 minus 2 equals to 1 minus 1 minus 3 plus 5 minus 2 equals to plus 1 minus 1 gets cancelled, minus 3 minus 2 is minus 5 plus 5, which is equals to 0. Since f of 1 equals to 0, so what we'll do, we'll write 1x into 1 by, find the derivative of this one, that is f dash of d. You're having f of d equals d power 4 minus 3d minus d cube minus 3d square plus 5d minus 2. So derivative of this will be, derivative of d power 4 is 4d cube minus derivative of d cube is 3d square minus derivative of d square is 2d, right? Minus 3 into derivative of d square is 2d plus 5 into derivative of d is 1 and derivative of constant is 0. So you'll get 4d cube minus 3d square minus 3 2s are 6d plus 5 minus 6d plus 5 into e power x. Now let's find f dash of 1, right? Quotient of this x is 1, right? So we'll find f dash of 1. We'll get 4 into 1 cube minus 3 into 1 square minus 6 into 1 plus 5 equals to 4 minus 3 minus 6 plus 5 equals to 4 plus 5. 4 plus 5 is 9. Minus 3 minus 6 is minus 9. 9 minus 9 is 0. Since f dash of 1 is equals to 0, so what we'll do? Already you're having 1x, write that x into, write 1 more x. Find the derivative of this, right? See here, we are having f dash of d. Now let's find, this is f dash of d, right? We need to find this derivative or derivative of f dash of d. That is f double dash of d equals to 4 into derivative of d cube is 3d square minus 3 into derivative of d square is 2d minus 6 into derivative of d is 1 plus derivative of constant is 0, right? So f double dash of d equals to 4 3s are 12d square minus 3 2s are 6d minus 6. So derivative of this is 12d square minus 6d minus 6 into e power x, right? So now what we have to do, we'll find f double dash of 1, right? F double dash of 1, which is equals to 12 into 1 square minus 6 into 1 minus 6 equals to 12 minus 6 minus 6, which is equals to 12 minus 6 is again minus 12 equals to 12 minus 12 0. We got f double dash of 1 equals to 0. So what we'll do now, we'll again find derivative of this, right? So write x square into 1 by 12d square minus 6d minus 6 into e power x. Now since f double dash of 1 is equals to 0, so what we'll do, we'll write 1x into 1 by, find the derivative of this, that is f triple dash of d equals to derivative of f double dash of d. 12 into derivative of d square is 2d minus derivative of 6d is minus 6 and derivative of minus 6 constant is 0, right? Which is equals to 12 to 24d minus 6 into e power x. Now we need to find f triple dash of 1 equals to 24 into 1 minus 6 equals to 24 minus 6. 24 minus 6 is 18, which is not equals to 0. Since f triple dash of 1 is not equals to 0, so we can replace this d by 1. Okay. Or you can just write x cube into 1 by f triple dash of 1 into e power x. You'll get the same answer for both. Okay. You'll get x cube into 1 by 24 minus 6 is 18 into e power x, or x cube into 1 by f triple dash of 1 value is 18 into e power x, right? So the answer is x cube e power x by 18. Therefore yp equals to x cube e power x by 18. See, we are having 4 roots, right? We got 4 roots. Here you are having 1a, right? Which is equals to 1. Which is, here 1 is also a root which is repeated thrice. So we'll get x cube here. You'll get some x cube by 3 factorial, not 3 factorial. You'll get yp equals to, since you're having a which is repeated thrice from auxiliary equation, so you'll get yp from x cube into 1 by f triple dash of d into e power ax, provided f triple dash of a not equals to 0. Okay, you can just do directly, but it is better to check every step. Okay, for f of d, f dash of d, f double dash of d, for a, for d equals to a. If anything, if you get somewhere which is not equals to 0, then you'll stop and write yp. At some point of derivative of f of d, you'll get not equals to 0 by substituting d equals to a. At that point, you'll write the particular solution or particular integral, I can say. Now let's write the general solution. Therefore, the general solution is given by y equals to yc plus yp. Then y equals to complementary function c1 e power minus 2x plus c2 plus c3x plus c4 x square into e power x plus particular integral is x cube e power x by 18. Therefore, our required solution is y equals to c1 e power minus 2x plus c2 plus c3x plus c4x square into e power x plus x cube e power x by 18. Just have a quick recap on YP. If e power ax, if you have some q equals to e power x form where a is a constant, then now particular integral will find particular integral using 1 by f of d into e power ax, right? Now we'll replace this d by a, then you'll get f of a, right? If f of a is not equals to 0, then we'll write or we'll replace f of d by f of a value, okay? Suppose if f of a is equals to 0, then what will do? Then it is only possible when a is the root of the auxiliary equation, right? That is, this a is a root of the auxiliary equation. Okay, when f of a equals to 0, then just proceed this formula. X into, right, 1x into, find the derivative of f of d. You'll get f dash of d into e power ax. Again, you'll find f dash of a, right? If